In addition to UMLs, the other kind of diagram that we draw is object memory diagrams, and those show static and dynamic memory as it changes for our program. So let's say we are going to make the printer queue. So we have a queue of printer jobs. So the memory diagram is going to start off with our static and our dynamic memory. And the static memory is when we declare things. So right here we declared queue, queue. So here it is, queue, and there's its piece of memory. So now let's deal with the second part of the line, the new queue section. And the new queue section runs the constructor. And when we run the constructor, we have all this dynamic memory set up for us. And we get all these private instance variables set up, and right here we assign a value into the count and a value into the head. The thing about the queue that you should remember is we're also going to have a tail that we're going to calculate a bunch of times, and that's where the end of the queue is. That's where we're going to enqueue things, and we're going to have a head, and that's where we dequeue things. That's the front of the line and the back of the line. Okay, so the next line we've got here is we're going to be enqueuing a new printer job. So when we enqueue a new printer job, we're going to go in here and we're going to grab the default constructors and we're going to be adding it into our queue. We're going to add it into the queue into the tail position. And the tail position is right here in 0. And once we're finished, we're going to add to count. So watch for there to be added something in the tail position here. The tail will be moved on and the count will go up. Watch for that. Okay, so the count went up, we added something there, and the tail moved on. And apparently the default information was name and time, so that's why it got in here. Okay, let's look at the next line. So the next line has us enqueuing another thing, but instead of using the default, now we're going to be using the other constructor. And when we enqueue it, we're going to be adding it to the tail, we're going to move the tail on, and we're going to add one to the count. So look for those things. Add one to the count, something's going to be added here, and the tail will be moved on. There we go. Okay, so those things all happened. Good. Now we're going to dequeue. And when we dequeue, what's going to happen is we go to the head position. That gets returned to the user. We don't actually delete it because it will get deleted later on when we save something on top of it. So we actually leave it right there in the queue. But what we do that changes it is that we're going to decrease the count and we're going to move the head over here. So what you're going to see that's going to change once I dequeue is the count will go down and the head will move over. So that'll change, and that'll change. Let's take a look. Changed, changed, changed. Okay, the tail remained where it was because that's where the end of the line was. Okay, so on the next line, I'm adding a different kind of thing. You'll notice here that I've declared a new variable. So that means I'm going to have a new thing in my static variable, and I'm going to have a new memory allocation. So let's look at it. Here it is. So we've got our new memory allocation right in here. Now, on the next line, I enqueue that object that I made, P. So what's going to happen is we are going to add it in this spot. We are going to move the tail on an additional position, and we're going to change the count. So watch for the count, a new thing there, and the tail will move on. There we go. And that is how you would trace this code. So queues are a bit trickier than stacks. I like stacks a lot better, they're easier. So let's take a look at some stack code. So here we go. Oh, I got the order wrong. Here we go. All right, so we've got our new sushi stack. So there it is, and it's been declared. So when we construct it, we create the dynamic memory. There we go, it's been constructed. And with a stack, we only have two things we're storing. So there they are, the count and also our data array. And then in the constructor, we set count to be 0. Cool. So the next thing we're going to do is we're going to push a new sushi on there. And so we're going to be using this constructor, and we're going to add a new thing in there. So when we add a new thing in, what we do is we go to the count position. Well, there it's this one because it's 0. And we're going to add a new thing there, and then we increase count. That order is important. So they're going to add and then increase count. So look for that on the next screen. There we go. Okay, so then the next thing we've got is we're going to have a spoon. We're going to call this constructor again. We're going to call it push again. So we'll be adding it to the count position. So we'll go to the count position, which is 1, add those two things. So notice that this is going to change and this is going to change. Okay, So on the next line, we're pushing a new sushi, and that's going to be our default constructor. So we're going to be adding a maki roll to the count position, which is 2, and then increasing the count variable. Okay, looking good. So next thing we're going to do is we're going to pop. So pop, what they have us do is they have us decrease the counter, and then we return the data that's here. We actually don't erase it, but it's no longer in play, if that makes sense. Okay, so then after that, we're going to push. Now this is a bit of a trouble. Where does it get pushed? Does it get pushed in spot 3 or is pushed in spot 2? Well, the code tells us that it is going to get pushed in the count position. The count is 2, so that means it's going to get written right on top of this one in that position. So our new sashimi is going to go there, and then the count will go up. So then if we pop again, what's basically going to happen is we're going to remove our counter, but again, that spot will be the spot where we're going to put the next thing on the stack. Okay, good luck with your memory diagrams.